I've moved on to checking the capacitors around the horizontal output tube and the damper tube, which is all down here in this corner. I think the horizontal oscillator is working because I had this set running a moment ago while I had the radio on, and I was tweaking this coil, and I could kind of hear some whistlings and effects on the radio while I tuned this coil. So I think the oscillator is running. I don't think the output or the damper tube is working properly. Now, first up, I'm checking this big capacitor down here. It should be 0.5 microfarad at 200 volts. So I got my probes across it. I'm using the second capacitor scale, which tops out at 0.7. So 0.5, if this capacitor is good, we should get an open eye way down at this end of the scale here. So let's see. Did you get a reading? Right about there, which is right around 0.6, 0.7. Alright, let's check for leakage. Well, that's not a good sign. Unlike the electrolytics, when you check paper and mica caps for leakage, the light flashes if they're leaky. This is only at 100 volts. This capacitor should be good for 200. If I got a 200, the thing really flashes like crazy. So that is a leaky capacitor. Got to replace that one. Before I do though, I'll check a few others around here. I'm checking this capacitor now, which should be 0.035 microfarad at 600 volts. So I should get a deflection somewhere around here on the dial. Well, I certainly don't get a full eye. Very, very minor fluctuation right around there. But certainly not a big wide eye opening like I should be getting. And if I check for leakage, oh yeah, we got leakage at 200 volts, 300, 400, 500. So that guy's definitely got to go. I should, what good cap should test like. Capacitance should get a very distinct sharp eye opening. This is a 0.033 microfarad cap, and on the dial we're right around 0.03. For leakage, that light should never come on. 2, 3, 4, 5. So unlike when you test for electrolytics and you get that glow as it charges up, you should never see the light flash when you're testing paper caps or plastic caps. I replaced another capacitor on the horizontal output tube, but still no high voltage. But what I wanted to show you guys is how the radio is picking up this horizontal oscillator. So I have the radio tuned to 600 kilohertz where there weren't any strong broadcasts. And when I adjust this horizontal oscillator coil, I can pretty clearly hear it on the radio. So I assume it's picking up some of the harmonics. Which is why I think the horizontal oscillator is oscillating. Maybe not at the right frequency, but it's oscillating. Of course, I can get a scope on that, which I should probably do, and see what it's actually doing. One of the annoying things with the SAM service info, though, is they don't actually show you what the waveform should look like at any particular point. But I think I can probably figure out pretty well where the horizontal oscillator is a good place to check, so probably somewhere around here. Here's the actual oscillator, and here's the coil I was just adjusting, this frequency here. So how about I get the scope on right about here and see what's going on. Okay, I can see we're way off frequency. I've got about 26.8 kilohertz. It should be 15.75. Try adjusting the tuning, or the oscillator slug rather. I don't know how much of a change I can make though. When you're off frequency that much, this little adjustable core isn't going to be able to make that much of a difference. I'm sure some of the capacitors are way off. It's throwing the frequency off this much. The flyback is meant to oscillate at 15.75, so if you try to drive it with a frequency that's nearly double what it's supposed to be running at, it's just not going to produce the high voltage like it should. So we've got this circuit here. There's a number of things that could be wrong. I'll check all the capacitors, of course, which is the most likely culprit, but also some of these resistors, like there's a 2.7 meg resistor in here. And carbon composition resistors typically drift upwards in age, and the really high value, the mega ohm resistors, tend to drift especially badly, so I'll check that as well. I discovered that one of the newer caps, this .002 microfarad cap, is supposed to be good to 600 volts. It's quite leaky even at 200. It just gets worse as the voltage goes up, so gotta replace that guy. And that 2.7 mega ohm resistor I mentioned is measuring nearly 3.7 mega ohms. It's buried down in there, so that guy has also got to go. Okay, I rebuilt that whole area around the horizontal oscillator tube, including these two capacitors and a bunch of resistors here. Also found some interesting stuff in the rider's documentation, including this note about production run 4, where they say to improve horizontal stabilization, a certain 150K resistor should be increased to 220. So I did, because I did have a 150 in the set. I also found some nice pictures of what the scope waveform should look like, and something interesting on this tube location chart, which shows that on early sets the fuse was underneath the chassis, just tacked in place like this. So Admiral certainly made a lot of changes to this set as time went on. Also noticed that back on this sheet, the first, or these production runs 2 and 3 were to improve sound. So one was to ensure proper bias on these output on the output tube. They changed one resistor, and then to decrease audio buzz, they made a few changes here. And then to decrease hum, they made these changes down here. So they definitely tinkered a lot with the audio. Considering how early this set seems to be, I bet none of those changes have been made. So I've got buzz or hum in the audio, I can make these production changes. Now, getting back to this, they show two test points here, D and C, which are on this coil here. Right now I've got it on the D terminal, and C is just on the other side of this capacitor. So the D waveform should look like this, and they say it's important to have these 2 points be of equal height. Well, you know, mine doesn't look that different, except the frequency now. So before it was much too high, now it's much too low. I'm down to about 13.5. And this other test point should look like this. So I'm going to set the camera down and do a little more poking around with the scope while you guys watch the scope display. Alright, first off, it says that this point here and this point should be of equal height. You can do that by adjusting the lock slug, which is on the back of that large coil assembly. So I've got my alignment tool here. I will make that adjustment. What this does is it helps the local oscillator, which just runs freely when there's no signal applied, it helps that lock into a signal when one is applied, because you want the local oscillator to be synchronized to the incoming signal so that the pitch is stable. Alright, so here's the coil. So it's going the wrong way, go this way. I like it when things work like they're supposed to, so by adjusting the slug I can definitely change the height. And they're pretty much equal. It looks pretty much just like that picture shows. Now for the other side, it's supposed to be a nice sawtooth. And it is. Cool. It's supposed to look like that. And we've got that. But we still got a big problem here because the frequency is wrong. At 12.7 it should be 15.75. Now the other side of this coil is the frequency adjust. Well, adjust it, but just like before, I don't think I have too much of a range here on the slug. I can change it a little bit. And just a 12 point. I may go lower, but there's no way I'm going to be able to make this go from 12.5 to 15 and 3/4 by just tuning the slug. So there's got to be either a resistor or capacitor that's still off, that's throwing off this frequency. So a little more poking around. So here's that coil I've been mucking around with. The slug on this end is that frequency lock where I made the peaks of the signal be equal height, and this other side is the frequency. That's this dual coil with the dashed line around it that they show here. So I've already replaced all this stuff, but there are a few parts over here that I haven't altered yet, and since that's right on that coil, this could definitely be a culprit. So one is this replacement capacitor. Have not checked that yet. And I got an 8.2K here, and a 22K hiding back there behind that capacitor. So I'll check those first, and then there are a few ceramic caps, one here, that are used for some feedback. Those rarely go bad, so that's the last thing I'm going to be suspicious of. Same with these ceramic trimmer capacitors. These rarely go bad. And there's always a possibility there's some shorted turns or something up with this coil. Amazingly enough, I actually do have a spare from a junk chassis I got a while ago. So worst case scenario, I could actually replace this entire coil. The capacitor across the coil was bad, even though it's one of the newer ones, so I replaced that. And the two resistors were about 30% out of spec, so I replaced those as well. So let's see if it makes a difference. I've got the scope hooked up to this point again. And nuts, frequency is still 13.74. It's closer. It was about 12.5, 12.75 before, but still not to 15. Try adjusting the coil, see if I need any closer. I can get it to about 14.5. Coil's starting to kind of bottom out here. 14.6 if I can get one more kilohertz. We'll be in the zone. Ooh. Just adjusted the lock coil. That's definitely having an effect. I don't know if you guys can hear that, but there's all kinds of crazy high-pitched noise coming out of this thing. Like it's trying really hard to lock. There's 15. There's 15.75 right there. But no high voltage, so we've still got some other issues going on. So now that the horizontal oscillator seems to be all right, we'll move on to the horizontal output tube. Alright, I went all around the horizontal output tube here and tested the capacitors and resistors. Two of the capacitors were replacements and they tested okay, a little bit of leakage, so I just went ahead and replaced those. Those are the two white caps you see down in there. But what was really bad was the resistors. Almost all of them were off, some as much as double what they were supposed to be, so I replaced almost all of those. Now it's time to give this another try. Sounds promising. You can hear all kinds of high-pitched squealings going on down in there. And hey, we've got a trace back on the screen. However, obviously no vertical whatsoever. Let's see though. You can play with the height and linearity. Get something back. Nope. Controls aren't doing anything. I also seem to have lost sound. Oh, there it goes. Huh. That was weird. The sound kicked in and the trace disappeared. And when I rotated the focus control, the sound disappeared, but the trace came back. And there it goes again. You know, I haven't tested it. This focus control might be bad. Yeah, I can hear it crackling in there. I'll turn the set off before it damages anything. You know, that was the same problem in this other chassis, if you recall. Someone had removed this control and replaced it and put a new rheostat in the back. This rheostat might be bad too, so time to check that. That is a pretty crucial component because it's not just used to focus the picture tube. It actually forms part of a voltage divider for this set. Let's see if I can find it on this schematic. On different versions of the schematic they put it in different places, so. Well, grab this other one. I know where it is on this one. Alright, sorry about that. I finally found it. It's down here in the corner. On the other schematic, it's way over here on the left. So, we got our rectifier tube, filter cap, filter choke, filter cap, and way over here to the focus control, power resistors, and then over here to the audio output tube. So, if this rheostat is bad, that means there will not be voltage going to the sound output tube. Yes, indeed, this focus rheostat is completely shot. It only makes contact between these two terminals where it's all the way rotated to the right, which is what I was playing around with before when I was going between this point and out where the audio was cutting in and out and the high voltage was cutting in and out. So, in hindsight, when I very first powered this set up, I did get a bit of a raster. I had high voltage. Then while I was working down in here, suddenly I lost high voltage. And then I started working over in this area. When in reality, I think all it was that I had rotated the focus control a bit, and that's why I lost the high voltage. Now that being said, when I got this up on the scope, the horizontal oscillator was running off frequency and so on, and there were bad components in this area, so it would have needed to have been dealt with at some point regardless. But the real reason why the picture suddenly disappeared was because of this rheostat, which was also bad on this set right next to it. And if you watch the video on that, someone had installed a new rheostat in the back of the set, rerouted the wiring, and I was lucky enough to come across an original control, and I rerouted the wiring and restored it to the original configuration. Well, now I've got the same problem on this set, so I took the rheostat that had been mounted on the back of this set and temporarily wired it in down here just to see what effect that has. So, it's possible that I might have to end up sticking this back here somewhere and running wires to it, like was on this set, or I could put this back into this set and take this control and put into this set. But, if I'm really lucky, I did find someone who's got a really beat up rusty 20X1 chassis, and I asked him if I could have the controls out of it, and he said yeah, so hopefully those will be on the way soon, but I have no idea if they're any good or not. But if they are, I will definitely be replacing this. In the meantime, I'll just leave this hanging here. Let's see how it works now. So hopefully now we should be able to get both sound and a bit of a raster on the screen. Alright, I've got sound. Huh, no raster then. I got out my multimeter and started checking voltages. First the 6BG6 output tube, and they were all fairly close except for the drive pin, which should be minus 0.5 volts, and I have minus 5 volts. So that's probably what's preventing the high voltage from appearing. But if you recall, we also had a problem with the vertical collapse. When I did have high voltage, we just had a single straight line. So then I checked the vertical oscillator and output tube, and I found that there was a huge problem with the voltages on that. That's V13 on here. We should have between 80 and 148 volts on pin 1, and pin 6 should have 380. I had virtually no voltage on either one of those pins. So I traced out the circuit, and it's supposed to be pulling voltage through this resistor. And when I checked it, well, one end isn't going to anything. It's supposed to be going to this capacitor right here. So when I had found a bad section on this electrolytic and I tacked in this replacement cap, I forgot to connect this lead. So I suspect once I do, it's going to make a difference. Alright, let's give this another try. Ah, now that is more like it. It's brightness, it's contrast, horizontal hold, vertical hold, volume, fine tuning. So focus is off horribly. I'll have to adjust it with that. And the height. Let's see, that's this control here. Alright, with the height maxed out, it's the best I can do. Oh, there's a linearity. There's two controls, height and linearity, and they kind of interact with each other. So you can see here it's stretched out at the top and is really mushed at the bottom. That's the linearity. And there's the height maxed out. Should I go in the other way? Oh, we're getting there. Oh, somewhere about there is not too bad. It shouldn't fill the whole screen because this is a rectangular picture, 4 units wide by 3 high, and there's a mask that goes over this, so this is about right. It seems like I get the best picture when the fine tuning is fully counterclockwise. But it seems like if I could go a little bit further, the picture might get even better. So what I'm going to do is adjust the oscillator slug. So there's a whole channel cut out here. What that allows you to do is get a tool, well, not like this, but where is it? Allows you to get an alignment tool like this down into this tuner, and there are slugs you can adjust, one for each channel. Very careful if you do this, because these slugs, if you push too hard, you can knock the slugs right out of the coil. So what I like to do is put the fine tuning at the center of its rotation, and then adjust that slug for the best picture. So right about there. Let's see if I can get that picture any better. Listen to the sound too. Usually there's a compromise spot between best picture and best sound. Aha. So right about there. That's better. Now if I go to either side of center, I can get it to be a little bit off the ideal. So what have we learned during this project? Well, for starters, although it is possible to reform electrolytics, I don't think it's worth the time and effort. I spent several hours slowly increasing the voltage on those caps, and in the end, I ended up replacing virtually all of them. And even the few that are still in the set are leaky, and I'm going to replace them anyways. So for example, this 4-section electrolytic, I've already replaced 3 out of the 4, and the 4th one's a bit leaky. Likewise, there's a 3-section back in here. I replaced 2 out of the 3 sections, and the 3rd one is leaky. Which makes sense, because the way these are constructed, it's like a big jelly roll, and if several sections are bad, the others are going to be failing too. This one is somewhat newer, and it does test okay, but it's still probably a good 50 years old or so, so I'll be replacing that too. Next, although it was fun to do, testing each one of these paper caps seems like a fairly pointless exercise, because virtually every single one I tested was either very off in capacitance or very leaky or both. So just go ahead and replace them all. Next, if something was working and you do a little bit of work and then it stops working, you probably made a mistake in the last section you worked on, which in this case was when I replaced this cap. I forgot to solder this resistor back on, and that's when we lost the vertical. Next, definitely worthwhile to grab a multimeter and get the voltage chart and start checking. That's how I was finally able to find out that I had made this mistake. Also helped me figure out that this focus rheostat was bad. Also, I know they're expensive and they're hard to find, but a tube tester, really invaluable. That's how I was able to find the bad 6AL5 on the audio. Now that the set is more or less working, if I was an unscrupulous individual, I could shove this back in the cabinet and throw it on eBay as a fully restored vintage TV. But I would never do that. So, my next step is to replace the last few electrolytics, and a much neater job than this. I imagine I will restuff these cans, and I'll go ahead and replace the rest of these paper caps, and I will check and replace any out-of-spec resistors. I found quite a few back in this area. I'm sure there's bad in the rest of the set. I also want to replace this power resistor. I really don't like these sand resistors. They often corrode and eventually they'll go open as the copper oxide eats through the wire. And finally, I will keep my fingers crossed that I can locate a good focus control here. Otherwise, I'm going to have to rig up something like this more securely. Here's a look at the set playing some actual broadcast material. Obviously the height's a bit mush still, but otherwise it's playing pretty well, I think. Alright, that's it for now. I hope you enjoyed this little restoration video on an Admiral 20X11.